Okay, dark energy, take one. What is most interesting about the dark energy hypothesis and the supporting observations is that it's a chapter in a longer story as to whether or not the universe has a history. Now you might say, well, of course the universe has a history. There's biological evolution, we have human history, archaeology, and of course we have the history from the Big Bang, right? Well, maybe not so fast, okay? So let me give you an analogy here. This issue came up in geology in a very clear way. So back in a century or so ago, there was this big debate in geology whether or not all the geological formations could be understood as having been formed by a uniform process. The idea was, volcanoes lift things up, wind and water, weather wear them down, new volcanoes come up, wind and weather wear them down. So anything you're looking at any particular point in time is due to these same universal processes over time. Okay, so that was the uniformitarian idea. Okay, and it's non-historical in some sense. Okay, it's just sort of it's always the same. So and the catastrophists were the people. They were looking at some of these geological formations. They said, wait a minute, now this can't be understood that way. This is there's sort of a unique event happened here. Well, I was taught when I was in school that the uniformitarians won and catastrophists were just silly. And then this thing came up with the asteroid 65 million years ago that supposedly wiped out the dinosaurs, and there are all sorts of evidence for this. And increasingly, there's evidence that there's a geological history, a history of unique events that you need to have some sort of narrative to describe it. It's not just same processes. No, you need to say, well, this happened, that happened, and that happened, and these are unique events over a period of time. So the ball was still up in the air now. So what we have to do here is apply this to cosmology. So the big story about cosmology really starts in 29. There's some preambles to this, but this is when Edwin Hubble reports his data. He looked at all these galaxies, and he looked at the light, and the light had redshifted. This is the big redshift idea. So, and the most straightforward interpretation of the redshift was all these galaxies were moving away from each other. Okay, cool. Well, if you extrapolate back, then that meant that at some point they were all together, okay, at the beginning. And all of a sudden, now you have, when you have a beginning, this is like a catastrophic event, the Big Bang. This is not like same processes, right? So all of a sudden, it looks like the universe has a history. Now, so in an attempt to rescue this idea of the historical universe, Fred Hoyle, Thomas Gold, and Hermann Bondi in 1948, this is 20 years later, put forth something called the steady state theory. And their idea was, okay, it's expanding, but the stuff at the edges dies off, and new matter is being created internally, and so this would, again, be a nice uniformitarian thing, just like the geological thing. So there's processes coming up, and so same thing over a period of time. Everything's great and wonderful. So they were attempting to save the uniformitarian view of cosmology, despite the fact that this Big Bang thing looked like everything was expanding. They were trying to okay, let's interpret it the other way. So what's going on here? Let's dig a little deeper. Where is the real conflict between this scientific uniformitarian mechanical idea of the universe and historical idea, the idea that it has to have a story of the universe, if you like, that's going to be different over time with built of unique events? Okay, that's the question.